Now when it comes to vectors, right, so we can represent the vectors using an arrow, right? So if you draw an arrow like this, right, the direction of the arrow shows the direction of the vector, right? So if you have one arrow like this, another one like this, right? Now this vector represents that way. So then this one is acting downwards. Okay, like that. Depends on the direction of the arrow, we can say that vector is on that direction. And you can see I have drawn it to two different sizes, right? So normally the length of this arrow represents the size or the magnitude of that particular vector, right? So that means when you see it like this, so we can understand that this one is a larger vector compared to this. Okay, right? Now, most of the time we can roughly draw it like this. Whatever the vector with the larger magnitude, we draw with a long arrow. Whatever with the smaller vector, we draw it with a small arrow, right? But there are some instances, some situations, we have to draw scale diagrams, right? Scale diagrams means like this, right? Now let's say this force is 10 newtons, right? So if you want to draw this one, you may have to take a scale. Scale means 1 centimeter equals 1 newton or 2 newtons. Like that, a suitable scale depends on the type of the force, right? Like the 1000 newtons, we can't use these scales. Then we have used like 1 centimeter equals 200 newtons or something. Like that, using suitable scales, we have to draw those vectors. Okay, so that can keep in mind because it's necessary for the next topic. Right? These are no need, right? Just keep in mind. Now, when it comes to vectors, right, now let's say you have two scalar quantities, right? Now let's say mass is a scalar quantity, right? And if you want to add two masses, right, you can just do it, right? So if you want to combine your mass and my mass, you can just add the two values, right? So if you want to add the times together, right? So let's say the time taken for you to go home after this, right? So let's say you take here to go to the main road, let's say 2 minutes, right? So then you stop, you go to a restaurant, so then you take like 10 minutes. Then restaurant you eat something, you take like 30 minutes. So then restaurant you house another 30 minutes. So then you can add all those times, right? But when it comes to forces, so any vectors, right? So you can't just add the vectors like that because of the directions involvement. The vector addition has to be doing in separate ways, right? So vector additions you can do in different situations, right? Right? Vector addition, right? Now, if the two vectors are in the same direction, so for now we just consider only two vectors. So like this. Now I explain it forces, but it is not only valid for forces; it is valid for any type of vector, right? So let's say there's a force acting towards this way, 100 newtons. This way, 200 newtons. Okay. You know, if you have an object like this, if two things pushing this object in the same way, now this one is pushing, this one is pulling. So then it is easy to push or pull this object. So that why? So combined effect of these two forces is like adding 300 Newton forces in this way, right? So therefore, when the two vectors are in the same direction, we can say their final result is just the addition of the two vectors, right? It is like 300 Newton applied to this way. Okay, so this is the sum of these two vectors, right? The sum of the vectors we normally call as the resultant vector. Okay, so their combined effect is resultant, right? Since these are two forces, we can say this one is the resultant force of these two. That means this single force will do the same job as these two are doing separately, right? So if you have 3 forces, 4 forces, right? So they are sum, right? So it is known as the resultant force. That means that single force can do the everything. All those forces doing only with that single force. Clear? Right? So then if the forces are in the same direction, it is like this. Right? Now let's say if the forces or the whatever the vectors are in the opposite direction. Right? Let's say towards this side there is a 10 Newton force. Towards this side there is like a 4 Newton force. Right? Now what will happen? Now one is pulling this way, the other one is pulling towards that way. Yeah. So then what will happen? When you have two of this like this, so object will move towards whatever the higher force is applied. Right? Yeah. This side. Right? So that means it will go in a way that the force applied like difference between this. Like that is large one minus the small one. Right? So therefore the resultant is resultant vector will be 6 newtons towards this side, right? And so it is same direction as the large one, right? So this is the difference between the magnitude. Difference between the magnitudes and same direction as the large force. Larger vector, right? So in this case, you just add the two magnitudes. Right? So it's in the same direction as the original vectors. Okay? So mention that. It's important one. Right? Now let's say these are if I in the same direction, opposite direction. Now let's say two vectors are acting something like this with a different angle between this way and even this way. Either way, same method. Okay. Say 5 newtons towards this way, 4 newtons towards this way. And let's say the angle between these two is 60 degrees. Okay. Now in this kind of situations, if you want to add the two vectors, we know there is if you push an object. Two people pushing object like in different way, the object will be moving somewhere in between, right? So that means the resultant is not either of those, so it has to go somewhere in between, right? So how do you find the resultant vector between these two, right? So there are ways now to find that we need the scale diagrams, right? The one I told you, we have to measure the length 1 centimeter equals 1 Newton or something like that. Then you have to measure and draw those lines, right? For example, if you are drawing this one, so if you take 1 centimeter equals 1 Newton, so then you have to draw 5 centimeters line like this. Clear? Right? Now, to find the resultant forces like these forces or the resultant vectors, there are actually two methods, right? The first method is, so we can call it as the parallelogram method. Parallelogram method, right? Now what we do is, right, so we have to draw a scale diagram. Right? So scale diagram, we have to draw it like this, carefully listen. Right? So first you have to draw it like this. Right? So you have to measure this length, 5 centimeters or something. Depends on your force. Right? So then you have to measure this angle and you have to draw the other one from the same point. Now this will be 4 Newton force represented by 4 centimeter line, like this. Right? So the main point is you have to measure the angle, you have to draw a scale diagram starting from the same point, right? So that's simple. Start from same point. Now after that, once you draw these two, right, what you have to do is we have to draw parallel lines to each of those. I have to draw parallel line to this. Yeah. So when you draw the parallel lines, what do you get? You get a parallelogram, right? So that's why we call it as the parallelogram, right? Now the two vectors you started drawing from this point, right? So then the diagonal goes to the same point. That means this diagonal. This is the one representing the resultant, right? Now since you have drawn it to a certain scale, right? So you can measure this length, right? So if it is coming as like 8 centimeters, so that means 8 into the scale is, you use 1 centimeter equals 1 Newton. So then 8 centimeters means 8 Newtons. So then the resultant force is 8 Newtons. Understood? Right? And the direction, we give it as an angle. Right? You can give either this angle or even this angle. So you can say the resultant is 25 degrees with the 5 Newton force. Clear? Right? So then complete the parallelogram. Right? So then the diagonal goes through the same point. Same point as the vectors gives the result.
So I will do the diagrams up here.
Sorry?
The diagrams, the roots.
Yeah, you can do this one, right? So we'll take this as third situation is when the vectors are at an angle. But do you have protractor? At least set square. Okay. No. Okay. So then when you are drawing this, draw it to the scale. Right? So draw it to the scale. Now this one you just roughly draw. Right? So after measure the length, now this one is 5 centimeter equals 1 you had measure 5 centimeters. Measure this 60 degrees. So this angle is 60. So then check what is the resultant. Now the next method is doing find the resultant force of this kind of vectors is the triangle. Okay, so here what you are doing is, right, so we draw, again we need the scale down, right, 1 centimeter equals certain value, right, so then you have to draw to a scale, right. First you draw one vector according to the scale. You can start with either of them, right, so either this one or this, right. So you have to draw it according to correct direction with the correct scale, 5 centimeters line, like this, right. So this is where I started, this is where you end drawing that line, right. So from the ending point, you start drawing the second one. Now second one is 4 Newtons goes that way. So then you have to draw it like this, from the ending point of the first one, right. So this angle has to be 60. Okay. So then now this is where you end the second figure. Second vector, right? So then if you join the starting point of both of the vectors, right, to the final point, start to the end. This is the resultant vector. Now if you compare with the previous case, it is, you can see it is the same answer, right? Now if you draw the vectors like this in a parallelogram, right? So we know this side and this side is equal, right? So in this case, this was the resultant, right? So if this is 4, then this side also has to be formed in a parallelogram. The opposite sides are equal, and they are both parallel, that means same direction. So that means this is your triangle, right? So therefore, it is giving you the same result. Okay. So start with the one vector. So then, from the ending point of the first one, you start going the next one. Start drawing one vector from the ending point. Start the second. Now even if you draw the other method, right? Now that means if you start with the 4 Newton vector, it will give you the same value, right? If you draw the 4 Newton, and so we have to draw 60 degrees to the horizontal like this, right? So this is the starting, the first vector. So this is the end point of the first one. So then you draw the second one like this, right? So the resultant is like this, and it's the same figure.
I will go
Yeah, if you no need to draw both, just keep in mind you can start with any vector, right? So that is this triangle, right?
there.
So that means this one is and this one is still the same. Right? So therefore, no matter whatever the vector you draw first, either way you get the same answer. Now, if you want, you can. Now they don't ask this much, but if you want, if you can extend this method, the triangle method, to add more than 2 vectors, right? Let's say. So you have vector like this, let's say A, this is B, right? So this is C, right? Now, if you want to find the resultant of all of these 3 vectors, right? Even if there are 100 vectors, you can use the same method, right? So what you have to do is, right? So whatever they will have their own magnitudes, right? So according to a suitable scale, you have to draw a scale diagram, one after the other, right? You can start from any vector. You draw it like this, the vector A. Right? So from this ending point of the A, you start drawing the B. Right? So ending point of the C, you can draw the C. Right? Now even if there is another one, something like this, so then you can draw the fourth one as well. Ending point of the previous one, you start drawing the second one. Right? So once you finish drawing all of those, right? So now you have a vector like this. So if you join the starting point with the end point, right, you get the resultant vector. Now this is the resultant of everything, right? So resultant of all the vectors. Understood?
Yeah.
Right? So just mention this as, right? So we can extend this method to add more than 2 vectors. More than 3 vectors. More than 2 vectors.
4.
Yes, fourth one.
So for A levels, we don't need the S level stuff, right?
No.
Just the A levels only.
Yeah. But basic concepts may be required, but no need. That means if the resultant force is 0, what will happen to the diagram? Now resultant force is 0 means
There's no need.
this red part has to be 0.
Yeah.
That means what? So then this diagram will be closed once you figure it. Once you draw all the vectors, it will give you a complete polygon.
Yeah.
Right? So if there is only 3 forces there, right? Once you draw like this, so it will give you a completed triangle like this. If there are more than that, for completed quadrilateral or anything, whatever will be a complete polygon. Is that clear? Understood? Right. Right. Now we discussed if there is an angle between the 2 vectors, right? So we have to draw a vector diagram, either triangle or a parallelogram, right? Now what? Now there is a special case. That is when the 2 vectors are perpendicular to each other, right? Let's say this is 20, this is 14 or something, right? So then if you draw the triangle, and what you get? So let's say you draw the 20 first. So from the ending point you draw 19 like this. Now this is also 90 degrees, right? So the resultant is given by this one. Okay. Now what is this triangle? It's a right angle triangle. So then in right angle triangle you can easily calculate this one. How? Pythagoras, right? So therefore if the two vectors are perpendicular to each other, we don't have to draw a scale diagram, right? It's not needed at all. We can simply do a calculation and find the result. Okay. So what is the way? So then r squared is equal to 20 square plus 19 square, right? Yeah, 400 and something is there, right? So then r is equal to square root of this thing. Clear? Right? And when you are doing the resultant force, always you will have to find the resultant force's direction as well. So that means you have to find an angle, right? So now since we didn't draw a scale diagram, we can't measure this angle either. So then how can you find that angle?
So we have to find the R, can do and
No need to draw. Again, you can use a simple calculation. Now this is right angle triangle. You learn trigonometry, right?
yeah.
Okay. So what is this side? Relative to this side, this angle, opposite. And this is no, hypotenuse is r.
No, that's adjacent.
This is adjacent, right?
And
So correct, right? So then to give the angle, you can take tan theta. Tan theta equals then opposite over adjacent 19 over 20. So then theta is equal to what? Tan inverse. If you take the tan to the other side, we write it as tan inverse 19 over 20. You can type this in scientific calculator. Okay, so there's a tan button there, right? So if you have calculator, I will show. Go home and check, right? So there's a tan button, right? So if you put shift and tan, there's a shift button. So shift and tan will give you tan inverse. So then when you press 19 over 20 there, so then when you put the equal mark, you will get this, whatever this and is it clear? Right? So then this is simply you can do with the calculation. When the vectors are perpendicular. Vectors are perpendicular. The vectors, right? Now, next thing we have to discuss is the vector subtraction, right? Before that, I need to discuss a minus vector, right? So, minus vector means like let's say I have a 10 Newton force or 5 meters per second velocity, right? So, let's say 10 Newton force this way or 5 meters per second velocity towards this way, right? So minus vector means it is in the opposite direction, right? So that means minus 10 means it is acting this way, right? So minus 5 means it is in the opposite way, right? So minus vector means the vector in the opposite direction. Understood? Simply as that, right? So that means this is A. That means this one is minus A. Same magnitude but in the opposite direction. Understood? Right? Write like this. And next part is the vector subtraction. Right? Vector subtraction. Now when it comes to vector subtraction, now let's say I have a vector A towards this way and B towards this way. What do I need is A minus B. That is vector subtraction, right? So here what we are doing is when it comes to subtraction, right? So we only know the addition method, right? So if I can make this into addition, I can use any of the methods we have discussed previously, right? So then I can write like this, A minus B. I can write like this, right? nothing changed, right? So minus the vector is plus. So then I can change the two signs like this, a plus minus b. Now minus b means opposite to this one. If b is this way, minus b is like this, same magnitude but only the opposite. Understood? Right? So now what do you have? I have vector, I have another vector. I am adding two vectors. So then I can use any method we have discussed before. Right? So if I use the triangle method, what do I have to do? So I have to draw the first A like this. So then from the point I ended drawing the first one, I draw the second one. Now second vector is not the B, it is the minus B. So then I have to draw like this. Yeah, so it is upwards.
Minus is up.
Minus, if the B is downwards, minus B is upward like this. Okay, okay, the opposite direction to the original one. So then this is my minus B. So then if I join this from here to here, what do I get? Resultant is the A plus B. A plus minus B this way. A plus minus B means what? A minus B.
So I just subtract the resultant.
Yeah, not subtract. So to find the subtraction, it's also the resultant means whatever the combined effect of the two vectors.
Then
Right?
it should be a minus value.
Yeah. So not minus, whatever this value.
Okay.
Right? So they are resultant. That means when you subtract these two, the answer is coming as this way. Okay? So how do we do it? Consider using the minus vector. Okay? We will have to do like this now. Let's say that an object is coming like this with the velocity of 10. Right? So it collides with the wall and it's bounced back with 8 towards the other way. Right? So if you have, acceleration is change velocity, right, divided by the time. So then if you have to find the change in velocity, so it is final velocity minus initial velocity. So final velocity is towards this way, 8, minus initial velocity is towards this way, right? So you are doing this vector subtraction. So when it comes to vector subtraction, right? So what we do is we add the minus 1, right? So 8 towards this way, right? So then we have to add the minus of this means in the opposite direction, right? So what do you have now? Two vectors in the same direction. So then what you have to get the resultant? We just add the magnitude. So then the vector change in the velocity is 18 towards that direction. Okay. So if you want, you can mention this as example. This change in velocity. This is known as resolving vectors. Right? Now we discussed if you have two vectors, so they have a resultant force. That means one vector which can do the same thing they both do together. We can do it with this one vector, right? So we can say it opposite way like this, right? So that means if you have one vector, we can use two vectors to represent that one. Right? So that means single job this one is doing. These two can do it on their own, right? So that means if you can convert two vectors into one, so then you can convert one vector into two as well. So that is what we call as the resolving method, converting one vector into two. Now,
I've got a question here. So
Yeah.
here we don't subtract it, right?
no,
Then it will be minus 2.
Yeah.
So then we are to get it to the same direction where we are adding.
yeah. Now, first when it comes to vector subtraction, what we do is we take the minus vector and add it. So when it comes to addition, so now both are in the same direction. So then you can add the two magnitudes.
So what if it was in this direction? Both people in this direction.
Both are in the same direction.
Yeah.
So then you can just separate the difference between two magnitudes. Oh, okay. Right. So then converting one vector into two vectors is what we call as the vector resolving. Now thing is, now when you are dividing into two vectors, now those two vectors can be at any angle to each other, but we are specifying this only to perpendicular to each other. right? So when you divide this into two vectors, those two vectors has to be perpendicular to each other, right? So these two vectors we normally call them as resolution components. Right? So normally simply we just say the components of these two vectors. Right? So that means when you are dividing this one into two vectors, those two components has to be perpendicular to each other. But they are not perpendicular to this one. Right? Okay. Here see how we are doing it. Now think about the parallelogram. Right? Now when you have now again, if you think back and forth, you have to think again and again, right? So if you are converting this into this, so these two resultant is this one, right? Now let's say this is the R vector, so I have divided into X and Y, right? So that means X and Y's resultant force is again this R, right? So then that means if you draw this parallelogram, so then this diagonal represents this R, right? Clear? Right. So this is one requirement when you are dividing into two components. This is one requirement. So those two resolution components has to be perpendicular to each other, and you have to know that at least one of the angle between the resultant and one of these components. This angle you should have known. Otherwise you can't do it. Right? So that means, for example, I have a force acting like this. Right, let's say 10 newtons or something. I want to divide this into horizontal and vertical components like this. Okay, so then I should have known this angle, 60 degrees, 40 degrees, or whatever. Right? So then if I know one angle, I can calculate. If I want, I can find this one as well, which is 30 degrees. Okay, so this angle or this angle has to be always known. Clear? Right? So let's say that angle as theta. Okay, right. So we know this is y, this is also y, it's like the triangle, right? Now what I know this one, I know this angle, I have to find x and y. Okay, right. Okay, what is the connection between r, theta and x? Yeah.
Theta is
This is the hypotenuse, this is adjacent. What is the connection between those two? Yeah, that is cos. So then cos theta is equal to x over r. So then x is equal to what? R cos theta. Right? So same way if you write sin theta, what is sin theta now? Yeah, so then opposite is y, hypotenuse is r. So then y is equal to what? R times sin. You understood? Right? So then how do we divide this? So then if you have a vector like this, right? So if you want these two components, if this angle is theta, right? So then x component came as r cos. Y component is this one. That one came as r sin. Understood? Yeah? First write this one, then I will tell you how to memorize this thing. Now this is how you memorize it. Right? Now you can say this is the one we know. This is the original vector. Right? So this is the angle. Now you can see this component is touching this angle. Right? So whatever the side which touches the angle, we take the cos value of the angle multiplied by the original one. Right? But this side is not touching the angle. So then that one is sin. Whatever the side touching the angle become what resultant force or the single vector times the cos value of the angle. The one is not touching the angle become the sin. Right? So that means if you have a vector like this, so 10 newtons towards this way, right? So this angle is 30. So then what should be this component? So you can say this the original vector is 10 newtons, angle is 30, right? So then this component becomes the force multiplied by cos angle. This side is, you can see, touching the angle. So therefore it become cos value of the angle. Right? So then this side will become the original vector times the sine value. Okay? So then this side, let's say 100. This is 45. What is this side?
100 cos
100
cos
cos 45.
100 sine 40.
100 sine 45. So then if we have it like this one is, let's say this is 70.
70 sine
No,
70 cos
touching that side angle.
70
Cos.
cos 20 20 sine 20.
Angle. Right? Now another case something like this. Now remember, so these two components, they don't have to be always vertical and horizontal, right? Now for example, if I have a vector like this, 30 newtons, so then I want it something like this. Now the two components has to be perpendicular. That's the requirement, right? This is, let's say, 25. So what is this one?
Cos
Yeah. How to write it properly?
30
30 cos
25
25. Other one?
30 sine
39, 25. Right? So you can type these values in the calculator and you can get the answer. What is the 100 cos 45? What is 30 cos 40? 25. Clear? Right? So I just mentioned that one as well.